Hello friend, welcome to plastic product design series. So previously we have uploaded the runner systems videos like what is mean by runner system, types of runner system, design guidelines for runner systems and the design consideration. So we have discussed thoroughly the runner systems. So it's a time for the revision and we will discuss the runner system in question and answer format. So this video I'm splitting into two halves, part 1 and part 2, and we are covering all the multiple choice questions here. Okay, so our first question is, what is the runner in the injection molding? So runner is the channel through which the molten material is flowing from a sprue to the gate. So it is a channel, and it is that runner is guiding the molten plastic material. So the runner distribute the material uniformly throughout the means to all the cavity. So here the main purpose of the runner in the multi cavity mode to spread the material uniformly and fill all the cavity at the same time. Why is the runner system important in the mold design? So to have the runner in the mold, so generally we use the runner system for the multi cavity mold and for the single cavity also, but in multi cavity runner plays a very important role to fill all the cavity at the same time, and runner maintain the pressure and the pressure of the material, and it flows to the all cavity at the same time and fill the all cavity at the same time. So runner system is very important in the multi cavity mold. So what are the common types of runner system? So there are two types of runner system actually. One is a cold runner and second one is the hot runner. So the one separate video is uploaded on this topic, types of runner. So in the cold runner you can see, so this one is in disengage position, this two half of the mold. So with the part we are ejecting the runner also. So while cooling, so we are cooling the part and the runner also, and we are ejecting the part and the runner. So here there is a vestige of the material here on the runner side, and we need to trim this runner from the part. Okay, so here the trimming will be manual or it will be automatic in the machine. Okay, so and here wastage of material is there, and this cold runner system generally used for simple part and for the small means for the less volume production, where we don't want the mass production. Okay, at that time we can use the cold runner system. And in the hot runner system there will be no wastage, because here we are not cooling the runner here, and we are not ejecting the runner here. Okay, so here there is a separate arrangement for the runner, and where we are keeping this runner in the hot condition, so that we can eject, or so that we can inject the continuous material in the mold cavity. So we are keeping this runner in the hot condition so that we can inject the continuous material in the cavity. And this one is very important, because we in a mass production we required these systems, and here we don't we are not removing the material here. Okay, so there will be no scrap here in the hot runner system. So for mass production, for complex part, and for the multi cavity mold, we use the hot runner system. How do you determine the size of runner? So the size of runner is actually depends on the material thickness and the material thickness and the material itself. Okay, and the viscosity of material, and the part complexity. So based on that we will decide the size of the runner. So there are different parameters for that. And the general guidelines, you can see the 60 to 80% of the wall thickness we need to choose to decide the size of the runner. So why is the runner balancing is important in the multi cavity mode? So to fill all this cavity at the same time, so for that purpose we need the balance runner. Okay, so that all cavity fill at the same time, so there will be no shortage of material, or some cavity will be feel overpacked, or some cavity are having the less material, so that will won't be problem if you choose the balance runner. So at that time all cavity fill at the same time and they will cool at the same time, so there will be no defects, or defects free product we will get. So what are the common runner shape and how do they impact the flow? Okay, so generally you can see these are the shape of the runner, like a full round, trapezoidal, U shape, half round, and a rectangle type. So these are the two halves of the mold, first half and the second half. So in full round, actually it is a half round is machined in the one mold and half round is machined in another mold. And generally this full round is most commonly used in the mold system, where we are getting the efficient flow and properly flow we will get here. So most of the time we use this full round, and sometimes we use the trapezoidal type of the runner shape. So here, how do you calculate the pressure drop in the runner system? So for calculating the pressure drops, we have some simulation software, and based on that we will calculate the pressure drop, and we can check how the material is flowing inside the mold. What are the disadvantage of unbalanced runner systems? Okay, so balanced system is very important to fill all the cavity at the same times. If the system is unbalanced, a runner system is unbalanced, like some cavities are filling earlier and some cavity are filling late. Okay, so for at that time there will be the overpacking, and the some cavities are short defects will come. Okay, so unbalanced system is try to avoid in the mold design, and balanced systems we need so that all cavity fill at the same time and there will be the uniform flow in all the runners. Can a mold function without a runner systems? Yes, of course. There is a setup like a direct sprue gating in the mold. So here we can directly inject from the sprue directly. We are injecting into the cavity. So this system is called as direct sprue gating. Okay. What are the typical guidelines for the runner layout in the multi-cavity mold? So there are the different runner layouts, or you can say the runner patterns, like circular type, H types. Okay, so these patterns actually we need to decide based on the part geometry, part wall thickness, material we are choosing, okay, and the size of the part. So the runner should be symmetrical to ensure the balance flow, and the runner length from the sprue to each cavity should be equal, and the runner diameter should tapered as it moves from sprue to the gate to maintain the proper flow. How does the material selection affect the runner design? So material is very important, so it may be like a high viscosity material, or it may be on the low viscosity material. So viscosity is very important, so based on that the diameter may varies. Like for high viscosity material, larger runner we can choose, and for low viscosity material we can go with the smaller runner also. So the material viscosity is very important. So what is gate and how it is different from runner? So runner is actually the channel through which we are guiding the molten plastic from a sprue to the gate, and gate is a small opening through which we are injecting the molten material in the cavity. So the gate will ensure that the material flow uniformly and fill the cavity completely. So friend, I hope you like this video. So this video is part 1 and this is for your revision purpose. So I hope you got some further information on the runner system. So in the next video we'll discuss the remaining questions and we'll discuss the answer also. So thank you for watching. See you in the next video.